Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, every week we profile the amazing, jaw-dropping scientific discoveries which are changing our world and revolutionizing our life. And with us today, we have a PhD in artificial intelligence talking to us about the unknown. We've talked about the known on this science show, but today we're going to talk about the unknown. The book is called We Have No Idea, A Guide to the Unknown Universe by Jorge Cham, who's a PhD in artificial intelligence from Stanford, and that's actually Daniel Whitestone, who is a professor in particle physics. So today we're going to talk about black holes, the Big Bang, antimatter, what happened before the universe was created. We're going to talk about all those things that we don't know about the universe. And so once again, the book is called We Have No Idea, A Guide to the Unknown Universe. So if you want to win a Nobel Prize in physics, if you want to go down in history as a pioneer in physics, then listen to this broadcast because you'll find out about all the things that we physicists don't know about the universe. And once again, the author of the book is with us today, Jorge Cham. He's a PhD in artificial intelligence from Stanford University, and he's also a cartoonist. That's right. The book is full of cartoons. It's for the average person, and it's for you to understand the limits of what we know about the universe. So, Jorge, glad you could be on Science Fantastic.
Hi. Thank you for having me. It's a pleasure.
Well, let's just jump right into the topics that you cover in the book. Now, if you get any high school textbook about astronomy, it basically says that the universe is mainly made out of atoms, starting with hydrogen, going to helium, and that stars are basically ovens that cook the higher elements. But is that really true? Do we really know what the universe is made of?
Yeah, well, I guess you could say that those high school textbooks are only about 5%, right? As some of your listeners might know, and as I'm sure you know, scientists have found that the universe is actually mostly made out of other kinds of stuff, not the atoms and protons and electrons that we've learned since high school. Most of the universe is made out of other stuff.
Like, for example?
Yeah, well, a big chunk of what we think the universe is made out of is something called dark matter. So that's about 27%. So roughly a quarter of the whole energy and matter in the universe is made out of something called dark matter, which scientists don't really know what it is. They've only sort of seen it indirectly through gravity and through the distortion of light when we look out at stars. And then another huge chunk of it, the majority actually of the universe, is something called dark energy. That one really baffles physicists. They don't really know what it is. They just have a cool name for it.
So in other words, of the stars we see at night, they only represent a tiny fraction of what is out there, and most of what's out there is basically invisible, right?
Yeah, most of the universe is the stuff that you can't see. It's kind of the stuff in between the stars, in between and among the stars that you really can't see. So really the stuff that you can see and touch and see out in the night sky is really only 5% of the universe. Most of the stuff is kind of this energy that's kind of permeating everything and pushing everything apart faster and faster that some physicists don't really know what it is or what could be causing it. And then a huge chunk of it is this stuff, dark matter, which is actually kind of pulling things together through gravity.
Now, we understand that most of that 5% of the universe, which is made out of atoms, is basically hydrogen and helium. And that we, made out of the higher elements like carbon and nitrogen, we only make up, I think, about 0.7% of the universe. So aren't we, in some sense, the oddball? Aren't we basically the odd man out? I mean, we're not made of what the rest of the universe is made of, right?
Yeah, no, we're definitely the exception to the rule. I mean, if you sort of think about it's like imagine you thought that reality and the whole universe, you thought you knew it your whole life, and you've been touching it and seeing it, but it turns out it's just to be like the tip of the tail of the whole elephant, and the whole elephant we don't know much about.
Okay, now, why do we have dark matter to begin with? I mean, physicists are basically pretty conservative. They're not going to adopt a new form of matter without a fight. So why do we believe in something that's invisible called dark matter?
Yeah, well, it was a pretty crazy theory when it was first detected. It sort of happened in the earlier part of the last century when people tried to basically check the box on something that they thought they knew. So astronomers could see galaxies that were really far away, and they could see that they were spinning. And so you can think of a galaxy like a merry-go-round in a playground, and you put a bunch of ping pong balls on the merry-go-round, and then you spin it. You sort of expect the ping pong balls to fly off the edges of the merry-go-round. And so that's kind of how galaxies are with stars. If you think of the stars as being the ping pong balls in a giant merry-go-round. So if a galaxy is spinning, you sort of expect the stars to fly off of the edges. But they don't. So we still have like a Milky Way galaxy where we're in, and we're still going around the Milky Way galaxy. So what's keeping the stars in is gravity. So gravity kind of pulls everything together at the same time that the centrifugal force is pushing them out. So there's kind of a balance there between gravity and the motion of the spinning. And so people thought, well, let's see how fast the galaxies that we can see are spinning, and let's see if it matches with the gravity that should be pulling in the stars from what we can see of the stars. So they sort of counted all the stars, and they said, okay, there's this much mass pulling everything together through gravity that we know of, and these galaxies are spinning this fast. And so they said, do these two numbers match together? And so, this is probably a project they gave to some lowly grad students just to kind of check off that these things made sense. But what they found was pretty interesting. They found that these two numbers didn't match. And so that's kind of what set off the discovery of dark matter.
Okay, Jorge, we're going to have to take a short commercial break. But after the break, we're going to continue discussion of We Have No Idea, a guide to the unknown universe. And once again, if you want to win a Nobel Prize in physics, listen to this program, because these are all the unsolved questions waiting for someone to solve them. Fantastic with Professor Michio Kaku. Today we have with us Jorge Cham. He's a PhD from Stanford in artificial intelligence, and he's the co-author of a new book called We Have No Idea, a guide to the unknown universe. So on Science Fantastic, we talk about the known universe, but today we're going to talk about the cutting edge. I mean, at what point do we simply not know about the universe? And once again, Jorge is not only an author, he's also a cartoonist. So let me ask you a personal question. How did you get into cartooning and then into artificial intelligence and then into writing a book about the boundaries of known physics?
Yeah, that's a great question. One that my parents are still wondering about my career choices there. But what happened was that I was very interested in robotics, so I went to get a PhD in robotics at Stanford. And kind of as I went through it, I noticed that it was a really interesting experience, to go get your PhD, to go to a place like Stanford. And I noticed nobody was really talking or telling stories about this whole experience. And so I started a comic strip called Piled Higher and Deeper, or PhD Comics, kind of about the whole experience. And I started putting these comics in the newspaper there, and then eventually online. And then eventually these comics kind of became basically more popular than the research I was doing and my day job. And so at some point I left academia to become a cartoonist, and part of that has been drawing comics about the whole academic experience, but also comics about science and research and explaining things. And then eventually the opportunity to write this book came along.
Okay, well, I should also say that in the physics department at my university, the City University of New York, we have a lot of PhD candidates agonizing about writing their PhD thesis, and they put cartoons on the wall, and they didn't realize that these cartoons are actually your cartoons about all the angst that PhD candidates have to go through, like a rite of passage, getting your PhD published and having it accepted. Well, let's just keep on going right into your book. The book, once again, is called We Have No Idea, A Guide to the Unknown Universe. Now, you talked about dark matter, which holds the galaxy together, and we know that dark matter is much more plentiful than ordinary matter, but it's invisible, very hard to detect. But now there's something called dark energy, which is even more mysterious and more plentiful than dark matter. So now, what is dark energy, and why should we care?
Yeah, well, dark energy, the real answer is that it's mostly just a cool name right now. It's just the name that physicists have given to this kind of energy that is apparently expanding the universe faster and faster. So if you sort of think about the whole universe from the beginning, there was a big bang, and then the universe expanded, and it became bigger, and everything was kind of flying out into space, and space itself was getting bigger. And so if you sort of think about that scenario, if you imagine it like a grenade exploding out in space, maybe, you might imagine that one of two things can happen. Either the pieces of the grenade, of the thing that explodes kind of keep flying off forever, or at some point, maybe the gravity between them starts to slow them down, and then it will eventually crunch them together. And so physicists, I learned, were curious about what would happen. Is the universe going to keep drifting away forever, or is it going to eventually clump together and crunch into a big crunch? And so scientists went out and they measured how fast all the stars out there are moving. Are they moving faster and faster, or are they slowing down, or are they staying at the same speed? And what they found, surprisingly, was that the universe was moving away from itself. It was expanding faster and faster and faster. It was accelerating. And so to have acceleration, you need a force, and to have a force, you need energy. And so this mysterious energy that's pushing everything apart, they decided to call dark energy. Dark because you can't really see it, and energy because it's kind of what's creating this expansion.
And isn't the fate of everything, the ultimate fate of the universe itself, whether we're going to have a big freeze or a big crunch, whether we're going to die in fire or ice, isn't that eventually tied to how much dark energy there is? That is, the fate of everything is dependent upon dark energy, huh?
Yeah, absolutely. If dark energy keeps the way it's going right now, the universe will just get colder and colder and further apart, and we'll definitely never get to another star, and it might even start to rip galaxies apart at some point, and so everything will just get really cold and lonely and sad. But if dark energy decides to retire one day and go away, then that might reverse, and we might crunch down into a giant crunch. And so that's kind of the fascinating thing that I thought while writing this book, is that physicists and scientists don't really know what this is or what it wants to do, or because it hasn't always been doing the same thing. So if you look back to the history of the universe, dark energy was sort of quiet at some point, and then it was very active at some point. And so if we knew more about it, like what it is or what it was made of or what was causing it, then we might be able to say, oh, it's going to do this eventually, and which would tell us how the universe will end.
Now, here's a question that even children ask, and that is, how big is everything? How big is the universe? So, well, that's a very simple question, but is there a simple answer to that question that children ask, and that is, how big is everything? What are your thoughts?
Yeah, no, it's a fundamental question. You know, imagine you didn't know how big your house was, or imagine if you didn't know how big your town was or your country. We sort of need to know how big the space we're in is. But then that's another fascinating unknown that we scientists don't know. Like, nobody knows how big the universe is. It's a very deep question. I mean, we sort of know how far we can see, so how far out into the universe you can see, but that's not necessarily how big the actual universe is. So and I'm sure you've heard, but some of your listeners may have heard of this concept of the observable universe. So the observable universe is the stuff we can see, how far away we can see, but that's different than the actual universe. The actual universe might be just right beyond the observable universe, or it might be way beyond the observable universe, or it might even be infinite. We really don't know, which I think is very fascinating and exciting and just full of possibilities.
Now, the Hubble Space Telescope can see way out there in outer space, backwards in time, in fact. And the Hubble Space Telescope, within the visible universe, can see about 100 billion galaxies. Now, each galaxy has about 100 billion stars. So there are 100 billion times 100 billion stars in the visible universe. Now, that's the visible universe. Isn't there another universe out there, which is the invisible universe, beyond the range of the Hubble Space Telescope?
Yeah, absolutely. Well, what happened was during the Big Bang and during something that happened after the Big Bang called inflation, what happened was that, you can imagine the Big Bang of things kind of flying apart. But the Big Bang, during inflation, what happened was that space itself, like the stuff we're in, expanded. So that also got bigger. And so not just something kind of moving outwards in a room, but the room itself is sort of got really big. And what I think scientists, the way scientists put it is that the room itself got way big, and also the stuff in it was flying apart. And so the question is, did the room get much bigger, much more than the stuff that was flying apart? And that's something that we don't really know.
Okay, we talked about space. Now let's talk about time. And that is, well, we had a beginning of the universe 13.8 billion years ago. We had the Big Bang. But again, here's a question that children ask, and that is, well, what happened before the Big Bang? What are your thoughts?
Well, I would just, pretty much every answer I'll probably give goes back to the title of the book, which is We Have No Idea. So yeah, we don't really know what happened before the Big Bang. I mean, first of all, it's pretty cool that we can see almost to the point of the Big Bang, which is really cool. So we can look at kind of the leftover radiation from some of that, what happened during the Big Bang, and we can kind of pick up the pieces of the Big Bang that we can see around us, and we can kind of reconstruct what happened at the almost at the Big Bang, but kind of what happened before that is really something that we have no idea about, and it's possible we may never know. But it's also kind of possible that we may know one day what happened before the Big Bang. Like, we might be able to kind of extrapolate and interpolate more into what happens, and so there's a lot of possibilities there, which is really cool. It's,
okay, well, Jorge, we have to take another short commercial break, but after that, we're going to continue a discussion of We Have No Idea, a guide to the unknown universe. With Professor Michio Kaku. And once again, if you want to get on national radio, if you want to ask a question, give us a call. The hotline number is 612-564-8135. When you hear the recording, leave your name, call letters to the radio station you're listening to, if you're listening to one, and the city you're calling from, and then ask that question. Make that comment that's always been bothering you, and perhaps your thoughts will be heard on national radio. That's right. We can put your thoughts, your idea on radio if you give us a call at 612-564-8135. And once again, our special guest today is a cartoonist as well as a PhD in artificial intelligence from Stanford University and the co-author of the book, We Have No Idea, A Guide to the Unknown Universe. It's a delightful book with lots of cartoons, lots of illustrations about the cutting edge of science, and is co-written by Dr. Daniel Whiteson, who is, in fact, a particle physicist. So if you want to know about the cutting edge of physics and science and cosmology, and if you want to win a Nobel Prize in physics, then answer some of the questions in the book. Well, let me say a few things about where I'm coming from. I'm a physicist. We physicists who work in something called string theory. Not everyone believes in string theory, but those of us who do believe in string theory believe that dark matter is nothing but the next octave of a vibrating string. That all the particles you see around you are nothing but vibrations, the lowest vibrations of a tiny, tiny little vibrating string. But it has higher resonances, and that's where dark matter comes from, because these higher resonances are, in fact, invisible. And what happened before the Big Bang? Well, if the universe is a bubble of some sort and the bubble's expanding, that gives us the Einstein's Big Bang theory. However, string theory says there are other bubbles out there, other bubbles that could collide or peel off baby bubbles, and that's called the Big Bang. So, Jorge, what are your thoughts? Because you've probably interacted with lots of scientists. What are your thoughts about possible answers to some of the questions in your book, We Have No Idea?
Yeah, well, it's interesting that you sort of brought up this idea of multiple universes. That's a really fascinating idea to me, and it's kind of really interesting to think about these ideas and to kind of think about what we call in the book the testable universe. So there's the observable universe, there's the actual universe, and then there's this kind of the testable universe, which is kind of how much of the universe we can actually kind of test with scientific experiments and scientific evidence and mathematics and theories and things like that. And so it's really interesting to maybe think about one day the testable universe maybe encompassing the multiverse or encompassing these other bubbles, these theoretical bubbles that you mentioned, or maybe even also mind-blowing is the fact that maybe we might never be able to test some of these, or we might never be able to know the real answer to some of these questions.
Okay, fair enough. However, there are some tests that are being proposed. One test is with the Large Hadron Collider, this gigantic atom smasher outside Geneva, Switzerland. We hope that one day we may be able to create dark matter in the laboratory and then check it against the predictions of string theory. And we hope to launch a satellite, the LISA, the Laser Interferometry Space Antenna, which could pick up gravity waves from the instant of creation. So we'll have baby pictures of the infant universe as it emerges from the womb, and perhaps, just perhaps, we might find evidence of an umbilical cord. An umbilical cord connecting our baby universe to a parent universe. In other words, Big Bangs happen all the time. And our universe peeled off from another universe. Now tell us about inflation theory, because inflation theory does seem to fit the data. In fact, it is the only credible cosmology theory that does fit all the data points. And it predicts the fact there could be a multiverse of universes. Okay, well, we have to take a short commercial break. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, we have with us on the line Jorge Cham, author of the book, We Had No Idea. Well, let's move on now to black holes. Even children know that black holes are these gigantic objects that we actually can see in outer space. They eat up everything. They're like the ultimate roach motel. All the roaches check in, nothing checks out. But then children ask the question, Daddy, Mommy, what's on the other side of a black hole? If you fall into a black hole, where do you go? What are your thoughts?
Yeah, no, that's a great question. Certainly, you would think the name sort of says it all. It's a hole that's black. But actually, it's not so much a hole as it is just kind of it's a singularity in space-time. So it's kind of this point. It's a really tiny point that is so dense, and there's so much stuff crammed into it that it creates this kind of weird irregularity in space-time. And so what you would think of as a black hole is actually maybe people have seen the movie Interstellar, or maybe they've seen pictures of black holes where you see sort of a circle that's black. So that's really just kind of a representation of the event horizon of the black hole, which is kind of the area, the volume around the point that is the actual kind of point of the black hole where light can't escape. So that's why it sort of looks black. And so what happens is at the edge of that black hole, that black sphere, that's kind of when you would definitely never be able to come out of it, even if you're going at the speed of light. And so what's inside of a black hole, I guess you would be asking what's inside beyond that barrier. Probably some pretty messy stuff. But that's one of the big questions that people don't know about is sort of what's inside a black hole. Definitely it'd be really hard to get into a black hole and check it out yourself. You would probably be ripped apart by all the gravitational forces and all of the energy that's, but there's a lot of interesting theories. Some people think that maybe, inside of black hole, there's a lot of weird things that happen with information, and there may be like a hologram of a whole other universe. But yeah, that's a huge question that people don't know about.
Well, there is an oddball theory. Let me get your take on it. If you look at the equations for a black hole and you put in the mass of the universe and the size of the universe, you find a match. In other words, the universe could be a black hole. The universe has an event horizon. There, of course, is the farthest star that you can see with our telescope, so there is an event horizon. And in some sense, we could be inside a black hole, in which case maybe we're on the other side of a black hole. That is, a white hole could be where matter is blown out the other end, so that black holes are where matter falls in. Where does it go? It goes blown out the other end in terms of a white hole, and that does look like the Big Bang. Now, of course, this is not adopted by every cosmologist, but what are your thoughts about the fact that, well, the universe itself seems to be a black hole?
Yeah, no, well, that's a great idea. Certainly, it's super interesting to think that, imagine if we are just one universe in kind of a sea of, as you mentioned, all of these bubbles, and maybe some people might speculate that maybe the black holes in our universe, maybe they contain also universes. But yeah, again, it's sort of hard it's fun to speculate about, and it may be true, and maybe we'll one day have the means to kind of go in there and probe it, or the mathematics to kind of extrapolate and be able to draw conclusions about that. But until then, I mean, these are amazing ideas to think about.
Yeah, and like you said, we have to have, the bottom line is proof, experimental proof. Well, it's kind of sad but Stephen Hawking, my colleague who recently passed away, Stephen Hawking never won the Nobel Prize because his theory that black holes radiate radiation, that radiation is too faint to be picked up. So some things in cosmology are not testable because of the primitive nature of our machines. Very sad. Science Fantastic with Professor Michio Kaku. Once again, with us today is Jorge Cham. And so we're talking today about black holes, about the Big Bang, about potential of time machines maybe even. And, well, before we end, Jorge, let me ask you a question. In your book, you also talk about life in outer space, maybe even intelligent life, like alien civilizations in outer space. What do we know about life in outer space, and do you think one day we'll ever make contact with aliens from another planet or star?
Yeah, that's an amazing question. One that really is very profound for us as a species. Imagine if we are the only living things in such a humongous universe. That would be a mind-blowing result. Or imagine if we are like one of many species and civilizations out there. That's also mind-blowing. So it's kind of one of these questions that has an awesome answer either way. But the truth is that at this point, we really don't know much about how likely life is to exist in other planets out there. I mean, basically, the problem is we only have one data point, which is us and the Earth. So we know that we exist, that life came about on Earth, and it gave rise to an intelligent civilization and to things like radio and books and physics. But we really only have one data point, and so we don't really know if it's a very common thing to happen or if it's an extremely rare thing that can happen. I mean, the most we can do at this point, I think, and that scientists have been working on, is look for how many other planets out there in the universe are similar to Earth, meaning that they're kind of sit at just the right distance from the sun, not too cold, not too hot, and they have the right size and maybe the right kinds of elements where maybe water could get there or other elements. And so that we know that is actually pretty common. So They estimate now that they're called exoplanets. There's maybe about 3 to 5 Earth-like exoplanets in almost every, on average, almost on every star out there. So if you think about the fact that there's billions and billions and billions of stars and billions of galaxies, there are a lot of Earth-like planets out there, which might make you think that definitely life has to happen, but we don't actually know how lucky we are or whether we're kind of destined to happen.
Okay, well, we had a number of physicists from the Search for Extraterrestrial Intelligence on Science Fantastic, and we usually ask them the question, how come they don't visit us? How come they don't land at the White House lawn to announce their existence? Or maybe they have, and it's all been covered up.
Yeah.
What are your thoughts about, well, why don't they visit us?
Yeah, well, there's a lot of challenges, I think. You know, the distances are just humongous. I mean, even if we had could travel at the speed of light, I mean, it would take us an enormous amount of energy and, you know, hundreds of thousands and maybe millions of years just to reach another galaxy, star. So there's kind of a lot of there's a lot of barriers to go visit your neighbor, just to say hi. And so there's a lot of barriers, and not just in space, but also imagine in time, maybe there was a huge, gigantic Roman-like civilization that populated the rest of the entire universe. But maybe it happened, 7 billion years ago, and we can't, they for some reason went extinct. Or maybe they're destined to happen in 7 billion years, and so we might never, right now, we might never get to kind of see this populated universe. And so there's just, I think, a lot of barriers between in space and time.
Well, let me give you my thoughts. You're an expert in artificial intelligence with a PhD from Stanford. One day we will digitize the human mind. And when we digitize our consciousness, we can put it on a laser beam, because laser beams can transmit information, and we can shoot it to the moon. So in 1 second, our consciousness will be on the moon. 20 minutes will be on Mars. 4 years will be on the nearest star. And we could explore the universe on a laser beam at the speed of light. And then every time we reach a distant star, we simply download our consciousness into a mainframe computer and then put ourselves into an avatar that has super strength and can live on distant planets in the universe. So laser porting, as I call it, would be the most convenient, fastest, safest way to explore the universe at the speed of light. But what are your thoughts? Because you work in artificial intelligence.
Yeah, well, technically I was robotics, and I worked in cockroach-like robots, which are intelligent but not that intelligent. But no, yeah, that's a fascinating idea. I mean, I watched Westworld, which is a television show on HBO, and that explores some of these ideas. And, consciousness is such a tricky thing that, you can maybe debate a lot about. But, yeah, pretty soon we might be able to have artificial intelligence maybe copy ourselves, and then it gets really tricky, right? Like if you make a copy of yourself and then you beam that to the moon or somewhere else, which is the real you? Is the real you the copy that's staying on Earth, or is the real you the copy that went out to explore the universe? So we
also asked a number of people in artificial intelligence this question, and that is a question that children ask, and that is, what happens when the robots become smarter than us? We don't know when it's going to happen, but it could happen, and will they take over? What are your thoughts about what happens when robots become smarter than us?
Yeah, well, in some cases, robots are smarter than us already in many things, in very specific tasks, or just in terms of processing power. I'm sure they can sort through things faster than we can, and maybe recognize things more than we. But, I have a very optimistic view about robots. I think that, hopefully humans always keep a hand on the electrical plug.
Okay, Jorge, we're going to have to wind up on that note. But once again, if you want to find out more about these things, get a copy of his book. The book is called We Have No Idea, A Guide to the Unknown Universe by Jorge Cham and Daniel Whiteson. Good day.